let's get into the statistics of Lean Six Sigma. In this session, we'll talk about basic statistics. We will not get too in-depth. Descriptive statistics help us to identify the data that we have in ways of explaining it. We'll compare that to a normal distribution and talk about graphs. So, data types. There are two categories or umbrellas of data types: quantitative and qualitative. Quantitative sounds just like quantity, and there's some number associated with that. Within quantitative, there are two types: discrete and continuous. Under the qualitative side, sounds more like a quality. Well, there's some sort of attribute. It's not numeric data. There are three types of qualitative data: categorical, ordinal, and nominal. Nominal data, you can see, is names. They are independent categories. Ordinal data has some sort of rank associated with it. It could even be tall, medium, short. It can be gold, silver, bronze. Interval data has some sort of relative value. There's a magnitude that we're measuring. And ratio data has a proportion there. There's a ratio scale that we're using. Discrete data is countable. An example would be number of defects or number of cars in a parking lot. Continuous data means that there are possibilities in between two observations. It's a continuous scale. It's also referred to as variable data. Attribute data is on the qualitative side. Binary data is go, no go, red, green, pass, fail. There are only two possible numbers. That's why it's referred to as binary data. Nominal data is more names. They are independent categories of each other, but more than two of them. You can mix this order up and it doesn't affect the integrity of the data. Ordinal data, you cannot mix it up. There is an order associated with it. Some basic statistics, or the basis of statistics, you can see here. The first phase of data is raw data, which is just your numbers. The second phase is descriptive statistics. We want to transform that data arithmetically so that it explains something to us, it talks to us. There are two theories within statistics. One is deductive, which is where we have a known universe. We know what the population consists of. Therefore, when we take a sample, we know what that sample is a portion of. Versus inferential statistics, that we have an unknown, we have no knowledge or very little knowledge about the population or sample. So when we take a sample from that population, we have to do everything that we can to ensure that it's a good representation of that population. And then the homogeneity question always comes up. You must be proactive when doing this and not reactive or ignorant to the variation that this can bring.